Hi, I'm Yekta. I am from Dubai National School, class of 10A, and my favorite subject my favorite lesson in physics is work and energy. We have a bunch of different definitions for work and energy, but in physics, work means the action or force done in an object that displaces the object, and energy is the ability to do work. First, let's talk about work. The formula to find work is W equal FD cosine theta, which is work equals to force times displacement theta. Cosine theta. Theta is the angle between force and displacement. Now, let's talk units. The SI unit of force is Newton, also written as N, while the SI unit for displacement is written as meter, also written as M. So that will make the SI unit for work N times M, but they simplified it into joules and will be written as a capital J. Work is a scalar quantity, which means it has both a magnitude and direction, and we can tell if it's positive, zero, or negative. How? We're about to find out. If the force and displacement have the same direction, it's positive. This means that the theta is equal to 0. And if we calculate cosine 0, we will get 1. This also means that the maximum work being done is when the theta is 0 and the object is speeding up. And always remember, if it's positive, then the work is being done on the object. To know if it's 0, force and displacement should be perpendicular to each other. So the theta will be 90 degrees. And if you calculate cosine 90, you will get 0, which makes displacement and work equal to 0. And lastly, how will we know if it's negative? Well, if force and displacement have opposite direction, then it's negative. And the theta will be 180 degrees, because if we calculate cosine 180, we will get negative 1. This also means that the object is slowing down, but work is being done by the object. What is the relation between work and force, and the relation between work and displacement? Work and force are directly proportional to each other, and work and displacement are also directly proportional to each other. Now that we know this, I have a question to ask. What will happen to work if we double the force, if we double the displacement, and if we double the force but the object stays at rest? Well, if we double the force, work will also double. If we double the displacement, work will also double. But if we double the force and the object stays at rest, work will be at 0 because we have no distance. Now that we understand work, let's talk about energy. So we know that energy means the ability to do work. But what is energy specifically? Well, energy has two types, kinetic and potential energy. Kinetic energy is when an object is in motion, and potential energy depends on the position of the object. The formula to find the kinetic energy is Ke equal mv squared. M stands for mass, and the SI unit is kg, and the v squared stands for velocity, and the SI unit is meter per second. And lastly, the Ke stands for kinetic energy. And the SI unit is just like the SI unit for work, which is joules. We should know that kinetic energy and mass are directly proportional to each other, and kinetic energy and velocity are also directly proportional to each other. Now, I have a question. Does mass or velocity have more of an effect on kinetic energy? Well, velocity does, because it's squared. So if we double the mass, the kinetic energy will also double. But if we double the velocity, the kinetic energy will quadruple. Now that we know that, do you know what work kinetic energy theorem is? Well, work kinetic energy theorem is the change in kinetic energy equals to the work net, or delta Ke equals to work net. The change in kinetic energy is when Ke final minus Ke initial equals to the work net. There is also half mv final squared minus half mv initial squared equals f net d cosine theta. Another thing we should know is that if the final velocity is greater than the initial velocity, that means it's speeding up. So the work and the change in kinetic energy is positive. And if the initial velocity is greater than the final velocity, that means it's slowing down, and the work and the change in kinetic energy is negative. Now, that's all. We learned about work and energy. It was simple, easy, and straightforward. I hope you guys learned something new. Anyway, that was all for now. We hope to see you guys next time.